guys, now we can just start the next thing in mathematics, because before in the previous thing I just explained about little bit of extra things about the mathematics. So after 5 minutes of revision we can just start the remaining. So rank and solution of the equation, so eigenvalue and basics. So matrix is nothing but this just representation. Okay, this is row column, and like this slicing means it is column, this is row, this is column. Okay, vertical is column. So A equal to Aij m into n. Okay, matrix can be written as m into n. Okay, so ith row and jth column. Okay, m into n, and m and n is the order and size. Okay, so this thing I just row matrix only row will be, column matrix only the column will be there. So whenever it comes under the matrix multiplication, m into n into r. Okay, it means this multiplication, this 1 2 3, this kind of multiplication comes into m into n. So but addition, this addition plus plus plus, so m into n, it means n minus of 1. Okay, you can see here m into n minus of 1 into r. Okay, so n is nothing but number of column, and okay, this one is a normal thing. Next thing, matrix multiplication, it means both of the thing they might be asked. Okay, suppose how to say, means suppose the minimum number of matrix multiplication also they ask, means you have to just calculate in accordingly. Okay, next one is square matrix. I think so you will know number of row equal to number of columns, means 2 into 2. M and n, both of the thing will be same numbers. So diagonal matrix means only this diagonal will be 0. Remaining they won't consider, this diagonal will be 0. But upper triangular matrix means you can see the upper triangle will be entirely will be cover of the numbers, but lower triangle we won't consider. Okay, I think so you can understand. So main diagonal only should not, it means main diagonal down value should be 0. Okay, this should be 0. So this, it's about their case. Suppose if there is 0 0 0, they let us don't consider, because the diagonal down it's entirely 0. Okay, so you can just see this is upper triangle, yes, that's definitely, because you can see this 3 are 0. Okay, that's it. For lower triangular matrix, the upper will be 0. That's it. Okay, traces dependence, it means for it means only we need to add the trace element. That's it. A1 A2 A3. Okay, so next thing you can see, it means this one I suppose identity matrix means identity matrix A ij equal to, it means this one, because 0 1 0 like that, 1 0 0 1 like that. So okay, so next thing, this one. Okay, it means A of A inverse equal to I. Okay, A inverse of A inverse is equal to A. Okay, K of A inverse equal to, it means K will come, it means K is just a constant, so 1 by K of A inverse. Okay, A B inverse, the whole inverse, B inverse of A inverse. Okay, A B C, the whole inverse equal to C inverse B inverse of A inverse. Okay, I inverse is just I only. Okay, so this are the x, it means vector column, and y is vector column. So you can see this one x vector and y vector, this represents vector. So if we just take the magnitude, it means normal, it is length of vector, means it's one root of x1 square plus x2 square plus x3 square, and y is like this. Okay, so normalization of vector is v equal to x divided by mode of x. Okay, so mode of x, I think so you can understand. So if x vector dot means dot product of two vector is equal to 0, means it's orthogonal, but we have to just also check the norm. It means magnitude of the x and magnitude of y. If the magnitude of x and y comes equal to 1, so it is orthonormal. Okay, I think so you can understand. So orthonormal and orthogonal. Okay, so people might have difference between this orthogonal and orthonormal. So let me explain. In mathematics, what is meaning of orthogonal vector and orthonormal vector? So tell me why it is important, and relate this with fluid mechanics and thermodynamics and mechanical engineering subjects. So let us see, because sometimes in my point of view I do agree, because I am also learning good things. Okay, you can see if two products are said to be orthogonal, dot product is 0. Okay, you can see only 2D vector this one, and orthonormal means ortho perpendicular, normal means unit. Okay, so you can see this one. So you can see they provide independent direction with no overlap. Okay, so this simplifies matrix operation, easy to decompose matrix Q or an eigenvector. Orthonormal basic helps in vector projection and energy distribution. So you can see in velocity vector, you can see stream function and velocity function potential functions are irrotational or orthogonal. Okay, it's not orthonormal, it's orthogonal. So line of constant stream function is parallel to, wow, you can see, I think so that thing I just explained to you in fluid mechanics. So stream function will be like this, and velocity potential will be like this. Okay, these are the things comes in the category of the orthogonal. Okay, so in thermodynamics you can see orthogonal condition helps in definition independent thermodynamic property. Okay, this PdV, it means work equal to P times of dV, and heat equal to Q equal to TdS. So they are independent. Okay, So I can see this is temperature, this is heat entropy, this is it means pressure, this is volume. Okay, so you can see are independent. So in the statical thermodynamics, I think so you can understand Schrodinger equation also for the molecule is been equal. So principal stress acts. Oh wow. See why because I just explained in the middle about the planar. So this will be the normal thing and this will be shear stress. So both are independent. So both are, it means perpendicular to each other. So according to perpendicular to each other, how the stress will behave. Okay. So finite element method, shapes, functions, or construction of orthonormal vector. So you can see orthonormal vector independent are not overlapping, and orthonormal is same as. Okay, I think so you got the point. Okay. Orthonormal check. Okay, this one okay. So this one next at y vector. Okay, definition you can see symmetric matrices A transpose are equal to A and A transpose equal to which one? Minus of is Q symmetric and A transpose equal to A inverse equal to this orthonormal vector. So A transpose equal to I. Okay. So sometimes in the condition also they will give you like this. Okay, A of A transpose equal to I. Okay. So these are the condition because while we are seeing problems we will just know. Okay. So symmetric A is equal to AJ and Q symmetric this one Aij equal to minus of Aj and main diagonal element are necessarily will be 0. Sum of all elements of Q symmetric matrix is 0. Okay. I think you can understand orthogonal. This orthogonal you can see this orthonormal set. Okay. This thing I think you can easily do it. And you can see this is orthogonal. Okay. Orthonormal or orthogonal sector. Okay. So complex matrix means just put the conjugate, that's it. So Hermitian matrix A inverse, it means A conjugate of A transpose equal to A Hermitian matrix. Skew Hermitian matrix A conjugate transpose equal to minus of A. It means unitary matrices A mode of A transpose equal to A inverse. Okay, A of A mode of A transpose equal to I. Okay, this is unitary matrix. So you can see main diagonal element must be real and it should not be imaginary. Okay, Aj equal to mode of Aj. Okay, skew Hermitian matrix main diagonal element are purely imaginary or 0. Okay, so determinant I think so you can easily do. So determinant can be negative, positive, fractional or 0. Okay, all types of value are possible. Determinant I'm just telling. Cofactor you can easily find it. Okay, adjoint A equal to cofactor of A the whole transpose. Okay, so next one A inverse equal to adjoint A divided by mode of A. Okay, this one okay. Okay, if a singular matrix means a mode of A equal to determinant it means mode of A equal to 0. Non-singular matrix means not equal to 0. Okay. Next one number of terms of expression you can see here how much term is there. So 1, 2, 3, 4, 5, 6. So 6 terms. So factorial of n. Okay, that's it. So this thing I just explained to you. Okay, done. So you can see mode of A product of main diagonal element whenever it is diagonal matrix or upper triangular matrix or lower triangular matrix. Keep on. Okay. So this one, next one adjoint mode of adjoint equal to mode of n minus of 1. Okay, mode of adjoint A mode of adjoint equal to mode of A n minus 1. Okay, that's it. So next one, if A inverse is asking means 1 by mode of A. Okay, what is the determinant of A inverse means 1 by determinant of A. Okay, that's it. Suppose if they ask adjoint of adjoint A means what is the value? Determinant of n minus 2 of A. Okay, I think so we're getting the point. The next thing we'll see this problem. So A cube. Okay, A is this much. So they are asking the alpha value. Okay, so alpha square minus of 4 the whole cube equal to 125. Okay, so alpha square minus of 4 the whole cube equal to 5 into 5 25. Okay, alpha square equal to 5. Okay, equal to plus or minus 3. Okay, sorry, plus or minus 3. So answer will be A for this. Okay, that's it. So let us see this one. So they have just okay trace equal to this one. Okay, A plus 5 plus 2 plus B equal to 14. So mode of A is 100. Okay. Asking what is the A minus B. Okay. So A plus B equal to 7. So the main possible 5 comma 2 will be, or 2 comma 5, or 3 comma 4, or 4 comma 3, 6 comma 1, 1 comma 6. So many thing might be the answer, but how we can just find it? But they have just given the mode of A is 100. Okay, this is the key point. So B, we can take this entire thing. B A03251002. So we can see this one. So this one determinant equal to 100. Okay, so you just make the multiplication. This one 5 into 2, this one 0, this one 0. You can see this one, it means A times of A, so equal to 100. So AB equal to 10. Okay, so go and place here. Suppose B equal to 10 divided by A plus 10 divided by A equal to 7, A square equal to plus 10 equal to 7 type of A square minus of A plus of 10. Okay, so now we can just calculate A will come 2 answers and also B will come 2 answers. So you can see 3 is the right answer. Okay, so next one they are asking the find the inverse of this one. Okay, inverse find is so much simple, guys. A inverse equal to adjoint A by mode of A. Okay, for 2 into matrix, what we have to just make this interchange and make this single change. Okay, 3 minus 2y, 3 plus 2y minus of I plus of I. Okay, that's it. So later on divided by mode of A. So 3 plus 2y into 3 minus of 2y minus into minus of plus will come, plus I square is minus 1. Okay, now we just calculate each and everything and we will get the required answer. Okay, that's it. So next one we can just think the rank of matrix. Okay, so why we need to find the rank? Because we are just determining the order of the matrix. The order of highest order, it means non-zero, minor of A, it is called as rank of matrix. So it means for this highest order is 4. Okay, suppose the one of the main thing is whenever the determinant is not equal to 0, the rank is whatever the thing is given. Suppose this is 4 into 4, the rank is 4. Okay, whenever the determinant is equal to 0, the rank is always less than 4. Less than. So it might be 3, 2, 1, anything. Okay, for 3 into matrix, same. 3 into 3, mode of A not equal to 0, the rank is 3. In the mode of A equal to 0, the rank is not 3, it is 2 or 1. Okay, I think so you are getting the point. Whenever it's been not equal to 0 only, that order depends. It means what is the order? The order will be the same for the rank. It means the rank is number of non-zero rows and number of non-zero columns. Okay, in echelon form in the matrix. Okay, row method, ECC, and column method, that's a normal thing. Okay, so the next thing is echelon form. Okay, if a matrix is said to be echelon form, 0 row if any must be at the bottom of the matrix. Okay, 0 row if any, okay, must be bottom of the matrix. So at the bottom of the matrix the 0th row should be. Okay, the next thing, the leading non-zero element in any row may be to the right side of the leading non-zero row in the previous row. Because I'll just tell you later on, because while we are just seeing the problem only, we can just get to know. Okay, the leading non-zero element in any row, if any, to be right side of the, okay, right side of the leading non-zero element in the previous row. Okay, so you can see this is a non-zero row and it is been in the right, it means in the where it's been in the entirely right side. This side we are just sitting. You can see 4, 3, it's been in the right side. Okay, so you can see this is a row echelon form. Okay, here the values should be and this side should be, it's like similar to the upper triangular matrix. Okay, okay, so So like this also the row should not be equal, like this also. So each and everything like this should be, okay. So if like this, you can see it's been like this, but here the number is been placement. This is also not a row echelon form. Let us here. So you can see here it means each and everything is been 0 also, it's row echelon form, okay. But you can see here while you are just taking and minusing, you can see if like this comes mean this is row echelon form, it means echelon form, okay. Rank of matrix is 3. Suppose if it's 1 here come, okay, it is not row echelon. So if 0 comes means definitely it's row echelon form. So what is the property of rank? So this one, okay, see the rank, okay, each and everything. So number of non-zero row is equal to 1, okay. This is also comes in the idea of row echelon form, okay. If all element of the matrix are same, then the rank of matrix is 1, okay. Okay, this I think so you can answer, because each and everything is same, just to make it minus above, each and everything will come the same, okay. So rank of matrix I think so you can easily do it, so I no need to explain each and everything. So you can see mode of A here equal to 0, so definitely the rank of the matrix will be less than 3, so 2 or 1 will be, okay. Okay, so they are asking the determinant of A inverse. So as I just told, determinant of A inverse is 1 by mode of A, okay. You just calculate the mode and you just put it down, that's it. So is this in row echelon form? No, because you can see here 2 is 7, 1 is there, okay. So next one, property of the rank, okay. Rank of A equal to R, okay, means this is non-zero minor of order R. Every minor of order higher than R must be 0, okay. So maximum rank possible is 4. I think so again understand. So here the maximum rank is possible only for the row, okay. Even though this one 1 2 3 4, okay, 1 2 3 4 row. So maximum highest possible means rank of matrix is 4, okay. So you can see A equals 6 into 4. So here what will be that? So you can see A into 6 into 4, okay, 6 1 2 3 4 5 6, 6 is that, but you can see maximum rank is only 4, okay. Why? Because only 4 into 4 submatrix can be formed, okay. So that's why the rank is 4, because even though it's 7 into 4 or 8 into 4, the maximum rank will be 4, because I just hold 4 into 4 submatrix you can just form 4 into 4, so more than that we can't form, okay. Next one, if rank of A m into n is there, so minimum of m into n, okay. This says that maximum rank will be m into n, in which is minimum, okay. You should take the value will be maximum condition. Next thing is rank of A equal to rank of A transpose, okay. So because determinant of A is determinant of A transpose, okay. The next thing, if rank of A equal to 0, then it means determinant of A equal to 0, or generally mode of A, it means rank will be 0, so null matrix A 0 0 0, so everything will be 0. So next thing, rank of AB minimum, which is rank of A and as well as rank of B, okay. Which is minimum we have to just take. So rank of AB is minimum of rank of A, rank of B. So in this while we are having a both of multiplication, which one has lesser rank, we need to consider that one. Next thing is same. So rank of A transpose equal to rank of A and A transpose. So square matrix of A n into n equal to rank of A n, okay. So if mode of A not equal to 0, so A is non-singular matrix or non-immutable, okay. Next thing you can see rank of A less than n, okay. If mode of A equal to 0, it means A is non-singular, A is singular matrix, okay. So you can see since its rank of A equal to 2, then what is that? So we can find, you can just say determinant of A equal to 0, okay. We can just calculate as it is, okay. So next one you can just see system of linear equation. So it's about linear equation. Vector system of m equation is n unknown. Okay. This thing is a common only. So if whenever m is less than n, it is undetermined linear equation. If m is less than 1, undetermined linear equation. This thing I don't want to explain bigger, so because just let us know. Okay. So next thing, the matrix will be given. This is here. This is entire thing will be x, and this entire thing will be b. Okay. So A x equal to b. A is coefficient matrix, and b x is solution matrix because we need a solution matrix, and b is column matrix. Okay. So Ax equal to b. So if b equal to 0 means it is homogeneous linear system. If b is not equal to 0, it is non-homogeneous linear system. Okay. I think I can understand. So next thing is there are little t type of solution. One is unique solution, infinitely many solution, and no solution. Okay. I think so you can see this one. So unique solution means just one interaction will be like this. So whenever it's about infinite solution, you can see many solution. So like this, you can see line 1 and line 2 will just overlap each other. The next one is no solution. So no solution means you can see the both of the things will be parallel. So that is parallel. So L1 and L2. Okay, they never intersect each other. Okay. So unique solution, infinite solution are always consistent. Unique solution and infinite solution are always consistent, and no solution is always inconsistent. Okay. So some might have a little bit of doubts about this consistent inconsistent. So I think so you can see this one. What happened? Okay. So you can see consistent solution means at least one solution exists. Inconsistent means no solution exists. Okay. And x plus 2 you can see. So only one line is there, but you can see x plus 2, x plus y equal to x plus y equal to 3. Inconsistent. Both the two lines is there. So unique solution means the equation will be intersect at one point. Okay. Infinite solution means rank of A less than, it means rank of A b, this one number of unknowns. Okay. So no solution means it will be parallel. Okay. Energy balance equation must be consistent, otherwise design fails. For trusses, beams should be satisfied, the structure will be unstable. Let us see what's ChatGPT is given. So it means truss analysis, 3 triangle trusses. Okay. E of f equal to E of f equal to, you can get a unique solution for analysis. This is stable and remain. So we can just go for the next thing. So next one is non-homogeneous linear equation. Okay. So homogeneous means will be equal to 0. Non-homogeneous will not be equal to. So Ax equal to b. Non-homogeneous. Okay. In the non-homogeneous also there are two types. One is inconsistent solution and another is consistent solution. So inconsistent means rank of A not equal to rank of A comma B. So consistent means rank of A equal to rank of A comma B equal to of R. Okay. Rank of A equal to rank of AB equal to R. Okay. This is consistent. Inconsistent means no solution definitely will be. Inconsistent unique solution as well as the infinite solution will be. So rank of A equal to 1. Rank is less than 1. Okay, that's it. So n is number of variable and number of unknown. So next thing is so ax equal to b, infinite for infinite solution. What is the number of linearly independent solution or number of free variables, dimensions of solution space? So generally it will be n minus of r. Okay, number of linear independent solution, number of free variables and dimension of solution space will be equal to n minus r. Okay, so I think so you get the point. So if we just talked about this one means I think so you can easily do it. So it means for what only lambda u and the solution as number of solution each and everything. So you can just go for the final form. Suppose you can see here if it means no solution means here both of the things should be, it means this alpha should be 0. Okay, so if alpha is equal to, it means it is equal to 6 means then rank of this one cycle will be 2 and this one will be 3, so no solution will come. If this both thing is 0 means so n is equal to 1 2 3. Okay, 3 and this thing will be entirely 0 means 2. Okay, you can see this one. So infinite many solution. So unique solution means this and this should not be equal to 6 and 2 only. So now the unique solution will come. Okay, so I think so you're getting the right. So it's not a biggest complicated thing, it's a normal thing only. So you can see they are asking the it means finding of the solution vector. Okay, which I just told about. What is this one? This one is entirely solution matrix. So they are asking solution matrix, so you need to convert into row echelon form. Okay, 0 0 0 and I think so you got the one. So later on you can see 0 of x, 0 of y and 2 of z equal to 2. Okay, z equal to 1 and later on you just calculate this one and y will come y equal to 0 and later on above means x equal to 5. Okay, so you can x y z equal to 5 0 1. So rank of a equal to rank of a comma b is equal to 3. So consistent and unique solution. Okay, so next one, reduce the row echelon form. So used to calculate eigenvectors. Used to calculate eigenvectors. Okay, so why the eigenvector is important you can see. So math means mechanical vibration, each eigenvector is some mode shape. It means eigenvector tells us how the structure bends in the mode, and thermodynamics eigenvector of diffusion matrix shows the principal direction of heat flows. And the fluid mechanics stability analysis eigenvector determines the perturbations of growth or decay. Stress analysis principal stress. Okay, okay. So for reduced row echelon form, you should calculate eigenvector. Okay, convert the matrix into echelon form. The leading non-zero element, if any, must be 0. The leading one is a non-zero element in the column. Okay, so it means you can see it is in a echelon form and leading element is necessarily b1. Okay, definitely. So no column matrix other than loading. Yes, definitely you can see. Okay, so reduce echelon form means one may be or may not be. Okay, just non-leading element. Okay, no column. Okay, so first of all each and everything we need to convert into reduced row echelon form. So I think so you can see this one, and each and everything we just convert to reduced row echelon. So 1 1 here 0 0. Okay, it is in echelon form and rank of a. So this is infinitely many solution. So okay, number of linearly independent solution is n minus r. So only one solution, only one linearly independent solution we will get. Okay, so this value should be 0. It means if it is me. Okay, this one. Okay, the entire column thing should be in a normal way. Okay, that's it. So you can see it means the top and bottom is also 0, and here the entire thing is 0, 1, 1 is in the reduced row echelon form. Okay, z you can see x minus z equal to 4 and y plus of 2 z equal to 2. So z we can just assume z equal to t. Okay, so make it the solution 4 plus t, 2 minus of 2t. Okay, plus t. Okay, you can see 4 plus 2 is 0, plus of t, this one 1 minus 2 of 1. Okay, this t. So this is linearly independent vectors. Okay, that's it. So basically it means one is basic variable x and y, and next one is free variable z. Okay, number of linearly independent solution and number of free variables and dimension of solution space equal to n minus of r equal to 3 minus of 2 equal to 1. So number of free variables, I think so you can understand. So next thing you can see homogeneous linear system. So ax equal to b and b equal to 0. Okay, so it means no inconsistent have, all equation will be equal in 0 and unique solution. So the next thing is a homogeneous linear system is always consistent since x equal to 0 is trivial solution. Okay, so you can see a m into n, it means both the thing rank of a equal to n means unique solution, trivial solution and zero solution. Unique solution, trivial solution and zero solution. Rank of a less than n is infinite solution, non-trivial solution, non-zero solution. Okay, a n into n, x of n into 1 equal to 0. So mode of a not equal to 0, mode of a equal to 0. So not equal to 0, rank of a is equal to n. Okay, so this one rank of a equal to less than n. Okay, so same ax equal to 0, it means as same when. So number of free variables are nullity means nullity will be n minus of r. Okay, next one you can see column minus row of a. Okay, that's it. So I think so you're getting the point. So we can just go for the eigenvalue and eigenvectors. Okay, so it means while taking eigenvalues and eigenvectors, only square matrix should be taken, only square matrix. Okay, so next thing you can see, let matrix A be the square matrix and scalar alpha, it means lambda, is called as eigenvalue of A if there exists a non-zero vector. Okay, Ax equal to lambda of x. Ax equal to lambda of x. Okay, characteristics equation a minus of lambda I equal to of 0. Okay, a minus of lambda I equal to 0. So this is characteristics equation. Okay, so a minus of lambda I equal to 0, this is characteristics equation. So next one, eigenvalue and eigenvector, you can just find easily. A equal to 1, 2, 2, 3, 4. Okay, so a minus of lambda I equal to 0. So a minus of lambda I equal to 0 means you can see scale. So just a simple, so a this one 1 minus lambda, 2, 2, 4 minus lambda equal to 0. So 1 minus of lambda, 4 minus of lambda, minus of 4 equal to 0. So calculate the lambda. What the lambda will come? 0 and 5. Okay, okay, it means now put lambda equal to 0. You can see lambda like this. So now we have to just convert into the echelon form and reduce to echelon form. You can see it is in echelon form, leading element is 1. Okay, bottom below that 1 is there. It is reduced. So basic variable is x. So because variable corresponding leading elements and free variable is y. Okay, basic variable is this one, free variable is this one. So x plus of 2y equal to 0. So y equal to t. Okay, x equal to minus of 2t. So go and apply in the above equation. That's it. We got the answer. This is reduced to echelon form. Convert to reduced to echelon form. This one, okay. Basic variable x equal to 1, free variable y equal to minus. Okay. So this one you can see 0 0 1 0 0 0. Find eigenvalue and eigenvector. So lambda minus alpha equal to 0 and the entire thing lambda equal to 0 0 0. Okay, this is a formula. Okay, if lambda equal to 0 is an eigenvector, eigenvalue algebraic multiplicity of 3. Okay, the before thing just simple, calculate eigenvalue and later convert into eigenvector. Okay, that's it. Okay, so for having the eigenvector we have to just make it sure into reduced row echelon form. Okay, for that this value should be 1. This value might be or may not be 1, but down value should be 0. Okay, so you can see here we have just put lambda equal to 5 here and we just got this one, and later on we have to convert this bottom thing into echelon form into 0 0, and later on we just want to make sure the top should be same. It means minus, sorry, 1 and 1 something. So you can see 1 and minus 1. So here the basic variable is x and the free variable is this y, minus 1 by 2. So y equal to t. So x minus y divided by 2 equal to, so x equal to t by 2. So put here t by 2 and t just this one. Okay, we just got the eigenvector. Okay, this is the eigenvector for this value. It means this is the eigenvector for x lambda equal to 5. Okay, so you can just see the next one. So if lambda equal to 0 is an eigenvector of geometric multiplicity of 2, so n minus of 2 are equal to 3 minus of 1 equal to 2. So if eigenvalue repeats 0, it is algebraic multiplicity. If it eigenvector repeats, it is geometric multiplicity. Okay, geometric multiplicity of linear independent eigenvector corresponding to eigenvalues. Okay, so next, trace of A21 is sum of eigenvalues and determinant of the square matrix is product of eigenvalues. So this is most important two equations. Trace of A n into n is sum of eigenvalues and the product of determinant is generally product of eigenvalues. If lambda equal to 0 is eigenvalue, then determinant of A equal to 0. Okay, if lambda equal to 0 is mode of A equal to 0. So eigenvalue of upper triangular or lower triangular or diagonal matrix or main diagonal element. Okay, eigenvalue of upper triangular or royal triangular or diagonal matrix or main diagonal element. Okay, so this one, if eigenvalue of this one is, this is, you can see eigenvalue of upper triangular, lower triangular diagonal matrix or main diagonal. Okay, so this thing you can see, if matrix A, this one A is equal to 1 for always, this one. So you can see the 1 1 1 1, so n is equal to 2 and lambda 1 and lambda 2 equal to 0, because generally this one mode of A equal to generally it will be 0, and this entire thing will be this one. So you can see for this 3 0 0 and for this one 4 0 0. Okay, eigenvectors corresponding to distinct eigenvalues are linearly independent. So you can see eigenvalues is lambda 1 lambda 2 lambda 3 3 0 0, and this entire thing will be like this. Okay, eigenvalues corresponding to distance eigenvalue are linearly independent. So guys, I think so we can just finish this one. So later on I'll just explain each and everything with respect to other perspective. So guys, that's it for this video, and let me see you in the next video. Until then, take care, bye bye, have a good day, thumbs up.